I'm going to show you something that Japanese butchers have been doing for over 200 years. It uses one ingredient, it costs almost nothing, and it makes everything the American food industry sells you for tenderizing meat look like a bad joke. I'm talking about cheap cuts here. Chuck roast, brisket, chicken thighs. The cuts that used to require a mallet, a marinade tub, and 2 days of hope. When I was cooking in Columbus restaurant kitchens, we threw all kinds of things at tough meat. Hammers, enzymes, acid baths. None of it held a candle to what I'm about to tell you. Before we get into it, if this kind of cooking information is useful to you, hit that subscribe button. I put out real food science here based on documented methods, not sponsored content or miracle products. No one's paying me to tell you this. Let's get into it. First, you have to understand why meat gets tough in the first place. Not just the surface level answer, the actual reason. Because if you know why something is tough, you can choose the right tool to fix it. And you'll stop wasting money on things that don't work. Muscle is made of fiber bundles. Each bundle is a group of muscle cells wrapped in a sheath of connective tissue. That connective tissue is mostly collagen. There are different types of collagen in meat. Type 1 and Type 3 collagen fibers are the main ones you're dealing with in beef and pork. Type 1 is dense, stiff, and extremely resistant to heat at lower temperatures. Type 3 is softer, more pliable, and breaks down faster when exposed to sustained heat. Tough cuts, chuck, brisket, short rib, have a high ratio of Type 1 collagen surrounding those muscle bundles. That's why low, slow heat can eventually soften them. But you're still dealing with a structural problem that heat alone doesn't fully solve. Inside those muscle fibers themselves, you've got proteins called myosin and actin. These are the proteins responsible for muscle contraction when the animal was alive. When meat is exposed to heat, myosin denatures first, starting around 140 degrees Fahrenheit. Actin denatures later, around 165 to 170 degrees. When actin denatures, it contracts and squeezes moisture out of the fiber. That's when chicken breast becomes dry. That's when a chuck steak gets that rubbery, chewy texture even after a long cook. You're not just fighting collagen, you're fighting the molecular structure of the muscle protein itself. Those are two separate problems happening simultaneously. Now here's what the American food industry's answer to this problem has been for decades. Meat tenderizers. The powder in the shaker. The stuff in the bottle. Walk down any grocery aisle and you'll see it. The active ingredients in most of those products are either papain or bromelain. Papain comes from papaya. Bromelain comes from pineapple. Both are what scientists call proteolytic enzymes, meaning they break apart protein chains by cutting peptide bonds. They work. Kind of. In theory. The problem is control. These enzymes don't know when to stop. They don't target connective tissue specifically. They attack all the protein in the meat, indiscriminately. If you leave commercial tenderizer on too long, you don't get tender meat. You get mushy meat. You get a protein paste held together by its own collapse. The texture becomes unpleasant. The flavor doesn't improve at all. If anything, papain adds a slight off taste to the meat surface that experienced cooks notice immediately. You're degrading the muscle structure without adding anything. That's the best case scenario for a chemical meat tenderizer, and you're paying a premium for the label. The other issue with papain and bromelain is penetration depth. These enzymes are large molecules. They work primarily on the surface of the meat. Unless you inject the tenderizer deep into the cut, the interior stays as tough as it started. So you end up with a mushy exterior and a tough interior, which is arguably worse than just starting with a uniformly tough piece of meat. At least then you know what you're working with. The Japanese figured out a better way a long time ago. It goes back to koji fermentation. If you've ever had miso soup, sake, soy sauce, or mirin, you've eaten the product of koji. The mold responsible is called Aspergillus oryzae. That's the scientific name. This particular mold has been cultivated and controlled by Japanese food producers for well over 200 years. Some historians trace documented use back to the Edo period in the 1600s and 1700s. The Japanese government has even designated Aspergillus oryzae as a national cultural organism. That's how central it is to their food tradition. Here's what koji actually does. When Aspergillus oryzae grows on a substrate, traditionally rice or barley, it produces a range of enzymes as part of its biological process. The relevant ones for meat tenderizing are proteases and amylases. Proteases break down proteins. Amylases break down starches. When you apply koji to meat, those proteases go to work on the collagen and the myosin and actin structures. But here's the critical difference from papain and bromelain. The enzymatic activity in koji is distributed, controlled, and slow. The breakdown happens over 24 to 48 hours, gradually, from the surface inward. It doesn't aggressively attack all the protein at once. It works methodically, the way long aging works on dry-aged beef. The result is meat that is tender without being mushy. The cellular structure remains largely intact. The moisture stays inside the fiber. When you sear that meat after koji treatment, you get the Maillard reaction on the outside, that deep brown crust, while the inside stays moist and textured. Not collapsed, not dissolved, actually tender. And the interior of the cut is affected, not just the surface, because the enzymes migrate inward over time. There's a secondary benefit that American tenderizers can't even approach. Koji fermentation produces umami compounds as a byproduct of protein breakdown. Specifically, free glutamates and nucleotides are released into the meat during the process. These are the compounds responsible for that deep, savory, almost brothy flavor you get in good miso or long-aged soy sauce. You're not just tenderizing the meat, you're seasoning it from the inside out, with real flavor compounds, naturally produced during the same 24 hours. That's not a marketing claim, that's documented food chemistry. This is why restaurant chefs who've discovered shio-koji won't go back to conventional tenderizing methods. They're not just getting a texture improvement, they're getting a flavor development tool at the same time. One ingredient, two results. That doesn't happen with a mallet or a bottle of powder. Now let me contrast that with mechanical tenderizing. Your mallet, your jacquard needle tenderizer, the blade machine at the grocery store. Mechanical breakdown damages the cell structure of the meat. You're rupturing cells, tearing fibers, breaking apart the tissue. The meat does become easier to chew, but you've also created pathways for bacteria to travel deeper into the meat. That's why the USDA requires mechanically tenderized meat to be labeled in grocery stores and recommends cooking it to a higher internal temperature than intact cuts. You've created a food safety concern while solving a texture concern. On top of that, moisture escapes much faster from mechanically tenderized cuts during cooking. You pound it to make it tender, and then it dries out in the pan. Those two things work directly against each other. Think about what happens to a mechanically tenderized chicken breast in a hot pan. The cell walls are already compromised before heat is applied. The moment the pan temperature starts driving moisture toward the surface, it evacuates fast through all those ruptures. You get a dry, tough result even though you physically beat the thing. The texture problem isn't solved, it's just traded for a different kind of failure. The science is not complicated. Koji's enzymatic process is superior because it's targeted, time-controlled, and additive. It adds flavor. It preserves cell structure. It doesn't create food safety risk. It works from the outside in at a pace that allows the interior texture to remain coherent. Let me tell you how I actually do this at home, because none of this is useful if it stays theoretical. For beef cuts, chuck, brisket, flat iron, skirt steak, I use shio-koji. That's koji rice mixed with salt and water fermented into a paste. You can find it at most Asian grocery stores for a few dollars. Some larger supermarkets carry it in the international section. You can also make it yourself if you can source koji spores, but buying the paste gets you started immediately without any extra steps. For a 1 to 1.5 pound chuck steak, I spread a thin layer of shio-koji paste on all surfaces of the meat. Not a thick coating, you don't want to overload it. A thin, even layer, maybe 1/8 of an inch, is sufficient. Then it goes in the refrigerator uncovered for at least 24 hours. I've pushed it to 36 hours on thicker cuts. Past 48 hours on thin cuts, you can start to get surface texture that gets softer than ideal. 24 to 36 hours is your window for most beef cuts under 1.5 inches thick. Pull it out of the refrigerator an hour before cooking. Let it come toward room temperature. Pat the surface dry with a paper towel before it goes in the pan. The shio-koji has already done its job inside the meat. You don't need it on the surface during the sear. Excess moisture and residual koji paste will prevent the Maillard reaction from developing properly. Dry surface, hot pan, high smoke point oil, and you sear it hard for 2 to 3 minutes per side. What you get on the plate is something that legitimately changes what you think a cheap cut can do. A $2 a pound chuck steak, treated with shio-koji for 24 hours, seared in a cast iron pan, sliced against the grain, it eats like something that costs 4 times as much. The connective tissue has been worked by the koji enzymes. The muscle proteins have been partially broken down uniformly through the cut. The umami compounds have developed in the meat itself. The texture is clean, not mushy, not rubbery. You can taste the difference clearly on the first bite. For chicken thighs, which don't need as much help compared to beef but still benefit tremendously, I reduced the time to 12 to 18 hours. Chicken protein is more delicate than beef. The enzymatic action works faster. 12 hours gives you noticeably more tender meat with that clean, savory depth. 18 hours pushes it further. Avoid going past 24 hours with chicken unless you want the exterior to get soft in a way that makes developing a clean sear difficult. Bone-in thighs can go the full 18 hours without problem. For brisket, I go the full 36 hours. Brisket is dense, heavily loaded with type 1 collagen, and benefits most from the extended koji contact. The flat is leaner and the point is fattier. The koji works on both, but the point benefits more because the enzymes can work through the fat alongside the protein. I trim the fat cap to about a quarter inch before applying the koji paste. Full surface contact, 36 hours in the refrigerator, then I either sear and braise low and slow, or if I'm outside, it goes on a wood cook at low temperature for several hours. Now here's something I want to say about my grandmother Nana Ruth, because this principle is not entirely new to American kitchens either. She grew up during the Depression. She raised 5 kids on a tight budget in rural Ohio. She bought the cheapest cuts available and made them into proper dinners, every night, without complaint and without shortcuts that cost money. One of her consistent moves was soaking tough cuts in buttermilk overnight before cooking. She didn't know the food science behind it, she just knew it worked. And it does work, for a different reason. Buttermilk is mildly acidic, with a pH around 4.5. The lactic acid in buttermilk denatures surface proteins. It begins to unwind and relax the protein structure at the very exterior of the meat. It's not a deep process. It doesn't penetrate far into the cut, but it softens the outer layer and begins to break down some surface collagen. Same direction as koji, using a biological or chemical agent to modify the protein structure before cooking, but executed with a much less powerful tool. Koji's enzymatic action penetrates further and works on a broader range of proteins. Buttermilk works mainly on the surface layer and benefits most from a long soak. But Nana Ruth knew the direction. She was working with what she had. People who cooked on limited budgets developed these methods because they had no other option. The Japanese refined koji tenderizing for similar reasons, making tough, affordable cuts into something worth eating. The food industry doesn't want you to know any of this because there's nothing to sell you. A container of shio koji costs $3 to $5 at an Asian grocery store. It lasts for months in the refrigerator. It works on beef, pork, chicken, and even fish. One ingredient, one step, 24 hours, no mallet, no enzyme powder, no special equipment. That's a problem for companies selling you 6 different tenderizing products with different brand names and identical active ingredients. I want to address one concern that comes up, which is whether koji is safe to use on raw meat. The answer is yes, unambiguously. Aspergillus oryzae is one of the most extensively studied food microorganisms in the world. It's been used in Japanese food production for centuries. It's used in the production of miso, sake, soy sauce, and other fermented products consumed by hundreds of millions of people daily. The FDA classifies Aspergillus oryzae as GRAS, generally recognized as safe. The koji enzymes deactivate during cooking at normal searing temperatures. There is no risk from properly prepared shio koji applied to meat that will be fully cooked. This is not an exotic or fringe ingredient. It's a staple of one of the world's most refined and documented food cultures. Let me also clarify the difference between koji rice and shio koji, because you'll see both in stores and online. Koji rice is the raw product, rice that has had Aspergillus oryzae grown on it, then dried or refrigerated. Shio koji is koji rice mixed with salt and water and allowed to ferment further into a paste or slurry. Both can be used for meat tenderizing. Shio koji is easier to apply evenly because it's already a paste with a spreadable consistency. Koji rice can be ground and used as a dry rub, or blended with a small amount of water to make a paste. Either form delivers the same enzymatic activity over the same time frame. Shio koji is my preference because the salt is already integrated, and the salt helps the koji penetrate the meat surface more effectively through osmotic pressure, the same principle that makes brining work. The application process matters. You want full surface contact. Every part of the meat should have koji paste touching it directly. If you leave a dry spot, that area doesn't benefit from the enzymatic treatment. I use clean hands to spread it evenly. Some people use a pastry brush. Whatever gets you complete, even coverage across all surfaces. Then the meat goes into a container or on a plate in the refrigerator. Uncovered works fine and actually allows some surface moisture to evaporate, which concentrates flavor slightly and helps the koji contact the surface more directly. Covered with plastic wrap is also acceptable. When you're ready to cook, pat it dry thoroughly. This step matters more than most people realize. The shio koji paste will burn and turn bitter at the high heat needed for a proper sear. The surface moisture from the paste will create steam and prevent browning. A properly dried surface on a properly hot pan is what produces that crust. The tenderizing work is already inside the meat. You don't need the paste on the exterior during cooking. Wipe it off, dry it completely, and then apply heat. The results are consistent and repeatable, which is more than you can say for commercial tenderizers or mechanical methods. 200 years of Japanese food production built around this organism isn't anecdote. Documented enzyme activity, documented umami compound production, documented protein breakdown. This is well-studied, well-understood food chemistry that produces a reliably better result than what the American grocery store aisle is offering you. If you've been settling for chewy chuck roast, tough chicken thighs, or brisket that requires hours of braise just to become edible, try this method once. The cost is minimal. The time is passive. You're not doing any work during those 24 hours. You put the meat in the refrigerator and walk away. When you come back, you have something fundamentally different from what you started with. If this kind of content is useful to you, real food science, affordable cuts, methods that are actually documented and repeatable, subscribe to this channel. I don't run ads. I don't take sponsors. I put this out because this information should be available to anyone who wants to cook well without spending extra money on products designed to create dependency rather than competence. Hit that subscribe button and you'll get every video I put out. Try Shio Koji on your next chuck roast. 24 hours in the refrigerator. Pat it completely dry. Cast iron pan, high heat, good oil. Sear it hard, rest it 5 minutes. Slice against the grain. You'll understand immediately why Japanese butchers have been doing this for 200 years and why the American approach to tough meat has been unnecessary from the start. They solved this problem a long time ago. Now you have the same solution. Use it.